In section 8.5, we will look at angles of depression and elevation. An angle of elevation is the angle formed by a horizontal line and the line of sight to an object above the horizontal line. Angle of depression is the angle formed by a horizontal line and the line of sight to an object below the horizontal line. So an angle of elevation is when you are looking up in the sky, maybe at an airplane or a bird or the sun. And an angle of depression is when you're looking down at the ground, maybe at an animal that's down there or just at the grass. In our first examples, we are going to describe each angle as it relates to the situation. So in the first one, angle 1 is an angle of depression, Snoopy to Woodstock, because Snoopy is looking down at Woodstock. And angle 2 is an angle of elevation, Woodstock to Snoopy. Woodstock is looking up at Snoopy. Okay, in our second diagram, angle 1 would be the angle of depression of the mountain peak to the hiker. Angle 2 is the angle of elevation from the hiker to the peak. Then angle 3 is an angle of depression, the hiker to the hut or the cabin. And finally, angle 4 is an angle of elevation from the hut to the hiker. Okay, and then that's the difference between angle of depression and an angle of elevation. Okay, number 1 says an airplane is flying 1,500 feet above the top of a building. The angle of depression from the airplane is 20 degrees. What is the distance from the front of the airplane to the top of the building? Okay, so angle of depression is 20 degrees. That would be angle 1. Because remember, depression is looking down. So the airplane's looking down at the building. Then let's go ahead and finish off our right triangle. So here's my right angle. And says it's 1,500 feet above the top of the building. That would be this distance here. And we want to find the distance from the front of the airplane to the top of the building. So we are looking for the hypotenuse. All right, so this just builds off our last section when we looked at trig functions and writing trig ratios to find missing sides in our right triangles. So in relationship to my 20-degree angle, 1,500 is opposite and x is my hypotenuse. So this would be the sine. So sine of 20 equals 1,500 over x. Then take the cross product. So x sine of 20 equals 1500. Again, remember to make sure your calculator's in degree mode whenever performing operations with trig functions. Then divide both sides by sine of 20. Plug that in the calculator, and we get 4,385.7 feet. So that's how far the tip of the airplane is to the top of the building. Number 2 says a surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. The angle of elevation to the top of the building is 35 degrees. How tall is the building? All right, so let's draw a diagram to see the situation. So we have a surveyor, and we have a building. Maybe with some windows. Okay, it says he's standing 200 feet from the building. He's looking up at the top. Here's our right angle. It says that it's an angle of elevation of 35 degrees. So that's this angle here at the base. We want to find how tall the building is. Okay, so in relationship to our angle 35 degrees, x is opposite. 200 feet is adjacent. So this would be the tangent. So tan of 35 equals opposite over adjacent. And take the cross product. So 200 tan of 35 equals x. Plug that into the calculator so that x is 140 feet. Now, if we go back, he is holding a 5-foot tall theodolite. So we have to add 5 feet to our 140 to get the actual height of the building. So the building is 145 feet tall. That's our final answer. Number 3, an airplane flying 8,500 feet above ground begins a descent 2 degrees to land at an airport. How many miles from the airport is the airplane when it starts to descend? And remember that there's 5,280 feet in 1 mile. All right, so let's go ahead and draw a diagram. So we have an airplane with some wings. And down below on the ground is the airport. So maybe there's a building down there, maybe some people waiting. Okay, so it's going to descend down. And let's go ahead and finish our right triangle. Okay, so if it's descending 2 degrees, that's our angle of depression. So that's this angle here. It's 8,500 feet above ground. We want to know how many miles it is from the airport, so we're looking for this distance. So in relationship to our angle of 2 degrees, the 8,500 feet is opposite, and the distance we're looking for, x, is the hypotenuse. So this would be sine. So sine of 2 equals opposite over hypotenuse. Then take the cross product. X times sine of 2 equals 8,500. Divide both sides by sine of 2. We get that x is So you get x equals 2,4,3,5,5,6.5 feet. And we want to know how many miles. So we need to take this number and divide by 5,280 feet per mile, because our feet will cancel out. So as a final answer, the airplane is about 46 miles when it starts to descend towards the airport. All right, and our last example, number 4. To find the height of the Delicate Arch in Arches National Park in Utah, a surveyor levels a theodolite with the bottom of the arches. From there, she measures the angle of elevation to the top of the arch. She then measures the distance from where she stands to a point directly under the arch. Her results are shown in the diagram. What is the height of the arch? Okay, so we are looking to find x. Now, in relationship to our 48-degree angle, x is opposite, 36 feet is adjacent. So this would be the tangent. So we'll take tan of 48 equals opposite over adjacent. Then we solve for x. So 36 tan of 48 equals x. And we get that x is 40 feet. But if you notice, we have to add in this 5 feet because of her theodolite. So to the height of the arch, will be that 40 feet plus 5 feet, or 45 feet total.